Good afternoon, 8th graders. It's Mr. Hale. Today we're going to focus a little bit more on the thermal energy and heat. We're really going to be talking about how thermal energy works with the states of matter. We've already talked about some of these topics. We're going to scroll through specific heat, but now we want to focus on this one. Thermal energy and the states of matter. Now there are 5 states of matter that we talked about. Here we're only going to show you 3, solid, liquid, and gas, but don't forget there is plasma, that phase of matter that's so hot, the molecules are moving so fast that they actually start to rip the electrons off. And you got Bose-Einstein condensate, which is the lowest phase of matter, where the molecules are moving so slow they start to act as one. But here we're really going to focus just on the solid, liquid, and gas. Now, over here, during the solid phase, the left side you have the temperature. The bottom side, the left axis, you have temperature. The bottom axis, you have your heat. When you're in a solid phase, as you add heat, your temperature goes up. When you're in your liquid phase, as you add heat, your temperature goes up. Even in the gas phase, as you add heat, your temperature goes up. But when you get to a phase change, when it's going to go from solid to liquid, all the energy is not going to move the molecules faster, it's going to start to break the molecules from the bonds that they have. Solid, remember, so tightly packed they can't move. When we get ready to turn that into a liquid, we got to break the bonds. So all the energy is going to break the bonds, not moving the molecules faster, but the actual breaking of the bonds. Thus, the temperature stays the same. Key point. Temperature remains constant during a phase change. So when you're going from a liquid to a solid, you see a horizontal line there. That means your phase is staying the same. Your state of matter, your temperature, is staying the same. You haven't changed your temperature. Over here, when we go from a gas to a liquid, notice the temperature doesn't change. The molecules are just being moved from the one style of liquid phase, getting energy but not moving faster to break free from that liquid bond into a gas bond. So we have to actually then use a different equation to calculate how much energy does it take to melt a piece of ice. How much energy does it take to freeze a piece of ice? Or from a liquid to a gas, how much energy does it take to condense? Or how much energy does it take to vaporize? So there are some equations we're going to go over with that. And let me pull up my little drawing board and we're going to go over some of those equations. We've already talked about this equation. Q equals M C delta T. But now the 2 new ones we're going to give you are Q equals M HF. That stands for heat of fusion. That's going to be from a solid to a liquid or a liquid to a solid. And Q equals MHV, which is going to go from a liquid to a gas or a gas to a liquid. These are constants, just like C was a constant, just like that C was a constant that we got from a table. HF and HV are constants. We're going to get those from a table. Okay, HF is right here, HV is right here, and C is right here. We're going to pull them from a table. So, when I want to ask how much energy does it take to change 50 kilograms, how much energy does it take to melt a 50 kilogram chunk of ice, right? How much energy does that take? I got to go, and I'm going to use this equation. Since I'm dealing with ice, it's going to go from a solid to a liquid or a liquid to a solid. I got to use this equation. Q equals M HF, because it's from a liquid to a solid or solid to a liquid. My mass is 50, but now I got to get my heat of fusion. Since we're dealing with water, we're going from a solid to a liquid. I need my heat of fusion to be this number here. And that was a really bad one. Let me get rid of that. I need that number to be that number right there, which is times 234. When we do that number, Give you guys a second to do it. 50 times 234 is what? If you need to pause it while you get the answer. If not, I'm going to give the answer. 11,700 joules of energy. Let's try another problem. If you need to stop the video, stop the video so you can try it out. Let's try another problem. Let's say I want to move and I want to vaporize 100 grams of aluminum. And I want to vaporize 100 grams of aluminum. What would I do? Think about it. I want to vaporize 100 grams of aluminum. That's a phase change. Since I'm going to vaporize it, will I use HF or will I use HV? Since I'm vaporizing it, I'm going to use HV. Okay, now I'm going to take my Q equals mHV. I'm going to find my V. I know my mass is 100. Now I got to find my V. Aluminum, and the V for aluminum is 10,500. Okay, so I'm just going to do that multiplication. 100 times 10,500. Hopefully you guys do not need a calculator for this. And you're going to get 10,500,000. What unit? A joule is our unit. Okay, now let's try one, and you solve this without my help. Remember, stop the video if you ever need to. Catch up, back it up if you need. Now, I want to convert I want to take 88 grams of copper. Okay, I want to take 88 grams of copper. I'll help you with copper. 88 grams of copper. And I want to change that 30 degrees. How much energy does that take to change 88 grams of copper 30 degrees? Look at your equations. Hopefully you choose the right one, which is Q equals, since we're dealing with a change in temperature, we're going to deal with that change in temperature. Q equals MC delta T, where your M is 88, your delta T is 30. Now we got to find your M. Your M, or not your M, you got to find your C. Your C, the specific heat for aluminum, is 4.71. Okay. Now, do the multiplication. 88 times 4.71 times 30. I'll give you a second to do that. $12,434.4. What unit? Joules of energy. Okay. So that's how we're going to do those practice problems. Now let's go back to our sheet. Now just a few little quick reminders about how to do things. When we're dealing with states of matter, you should know the phase changes. You should know from a liquid to a gas is vaporization, the gas to a liquid is condensation, a solid to a liquid is melting, a liquid to a solid is freezing. You should also know the sublimation, solid directly to gas, and now you definitely need to know deposition, gas directly to solid. All right. Hope you guys had a good time, and we'll be back. Next time we're going to talk about thermal expansion, why things heat up. This is Mr. Hale, KD2 LPM.